Hello everyone. In this video we will understand arrays with System Verilog in a very clear and simple way. We will be covering what is an array, single and multidimensional arrays, packed arrays, unpacked arrays, difference between packed and unpacked array, mixed multidimensional array. Now what is an array? An array is a collection of homogeneous data elements and it can be accessed using its name or one or more indices. Here in the example we can see we have taken the data type as res a 7 is to 0. This is a array, and again we are seeing here another array res 7 is to 0 mem 0 is to 255. It is a array, or you can say it is a memory of 256 locations, each of 8 bits. In Verilog, while declaring an array, we must specify both low and high range. But in System Verilog, we can simplify this by using compact declaration. Here you can see in single dimensional array, int low high, we have used verbose declaration. That means 0 is to 15. And in compact declaration directly we have written 16. Similar is the case with this multidimensional array, low and low high. Here is the verbose declaration and this is the compact declaration of this array. From this we can say System Verilog allows us to directly give size instead of range. Now packed array. A packed array is declared with dimensions before the array name. These dimensions must be specified in this format, MSB, then LSB format, not the size. And this is the syntax. We should give the data type, then the range, then array name. Now, one-dimensional packed array is referred to as a vector. What is a vector? A vector is it's a multi-bit data object. A data object which is multi-bit, and scalar is a one-bit data object. In packed array, the data bits are stored in contiguous set of bits with no unused space. And it is made up of single bit data types like bit, raise, logic or enumerated data types. Now, if we will consider a packed array and declare the packed array as signed, and the whole array will be considered as signed, but the individual elements may be unsigned also. And the maximum size of packed array is 2 to the power 16 bits. In using packed array, we can do bit and per select operations. This is how we will declare a packed array. This is the data type, this is the range, and this is the packed array identifier. This is another packed array this 31 is to 0 is the number of this is 3 is to 0 is the number of elements, and 31 is to 0 is the number of bits. And this is the assignment we use to initialize the array. Since it is a 128-bit array, we are initializing it this way. So you can see here 0 is to 3. So this array consists of 3 elements, and each element is of how many bits? 32 bits. That is 0 is to 31 locations. Next, coming to unpacked array. An unpacked array is one in which dimensions are declared after the array name. So this is the syntax, data type, and then array name. After that, we will give the dimension or the range. This is a verbose declaration of an unpacked array. This is the compact declaration. 0 is to 3, so 4 bits. 0 is to 7, so 8 bits. And we can initialize an unpacked array in this way. We have taken 3 bits, so I am initializing it all the 3 bits as 1, 2 and 3. And we can also assign a string to an unpacked array. Here I have considered byte array 4:0, and this word the string I am assigning in to this array. Uh, Here you can see that unpacked array can be of any data type. In packed array we have learned that it can be of only single bit data type, but unpacked array can be of any data type. It may be contiguous, it may be like contiguous bit of locations, or it may not be a contiguous set of bits, unlike packed array. And unpacked array may be of fixed size arrays, it can be dynamic array, it can be associative array or queues. These things we will be learning better in the next video. No single or range of element access available like packed array. We need to manipulate entire array address. No part select or bit select operations are not available in unpacked array. The maximum size of unpacked array can be 2 to the power 24. When the unpacked array is declared as signed, all the individual elements or bits will be considered as signed. And the application of unpacked array, it is used in RAMs, ROMs, and to create register files. That means it is very useful for RTL designers. Before going to mixed multidimensional array, let us make a comparison of packed and unpacked array. What we learned in packed array? In packed array, we need to declare the dimension before the array name, and in unpacked array, we will declare the dimension after the array name. Then the packed array are stored as contiguous bits, but in unpacked array, they are not stored as contiguous bits, or it may be stored also as contiguous bits, but it may not be stored as contiguous bits. And packed array is used for bit level operations, and unpacked array is used for memory modeling. This is a very important from interview point of view. Now let's move to mixed multidimensional array. So mixed multidimensional array is the mixed use of packed and unpacked dimensions in the array. This is bit. I have forgotten to write the name of the array. We'll write bit, then the array name, then this is the dimension of the array. So how we will like design this array? This design will be like 0:1. That means it will be having two layers. Okay. Next we have 0:3. This is the number of rows. There will be 4 rows in each layer. And 0:2. This is the number of columns. So we will be having 3 columns. Okay. Now let's move to another example of multidimensional array. With 0:2 array 0:1 0. So here we are using both packed and unpacked versions. So here this one is considered to be rows. So there are 2 rows and like 0:3. So 4 columns will be there. Okay. After performing the right hand side operations, then will the left hand side. Okay. Now this is 0:2. So inside this row again there will be 3 more rows. Okay. This is how we'll represent this array. If you like this video, like, share and subscribe my channel. Thank you.